Okay, let's see one more example. When q of x is of the form e power x, how to find the solution for a differential equation. Here we are asked to find the general solution. So general solution includes both yc and yp. Okay, y would be the solution for y would have two parts, yc and yp. How do I find yc? To find yc, what I should do is, first I should be writing the auxiliary equation. Auxiliary, as discussed earlier in the previous videos, I'll be writing the auxiliary equation. What that is I'll be writing the equation in D in terms of m. M minus 1 whole squared is equal to 0. Why? Because D is a differential operator. I can't write as I like when D is there. If M is there, it would be a quadratic equation, so I can handle it in any way and every way I like. Now, what are the roots for it? M is equal to 1 comma 1 are the roots for it. So, how do I write YC? The procedure that, as we have discussed in the previous videos, says that if the roots are real and repeated, I have real and repeated roots. So, what would YC have is C1 plus C2x e power m1 x. M1 is 1, so e power x would be yc. This is how I find yc. It's very simple. It's not finding, it's just writing. It's again like a shortcut. Now to find yp, how do I find yp? As discussed earlier in the previous example, same thing. I'll be writing f of d into y is equal to q of x. Okay. So yp would be what? 1 by f of d into q of x. Okay. Now q of x again has two parts. So I can split it like, first I'll be calculating yp1, which would be what? 1 by f of d. I can directly write d minus 1 whole square into 4 e power x. That would be my yp1. Yp2 would be what? 1 by d minus 1 whole squared into 8 e power 2x. Now, always, again, I'm stressing, as I have mentioned it in the previous video as well, what that is always make it a point to write f of d in terms of factors, so that if f of d goes to 0 as d is replaced by a, what's a? The a in the power of e power x. Okay. If f of d goes to 0, then I know a is a factor how many times, provided I write it as a factor. Now clearly I can see here d has to be replaced with 1. b power ax, in the place of a, I have 1. Okay. So d has to be replaced with 1. Once I replace 1, the denominator is going to 0. d minus 1 is going to 0. In the denominator, if it is a 0, the term goes to an undefined value, right? So what should I do? 1 is a factor of multiplicity 2. Multiplicity 2. Okay. So what should I do? Simply I'll just write yp1 as x squared by 2 factorial. Of course, 4 is a constant, can be taken out, e power x. Okay. Of course, I can cancel out 4 and 2 as well and rewrite it as 2x squared e power x. Yp1, that is. Coming to yp2. Let's see yp2. Yeah, I'll be replacing with 2. There's no problem with the denominator going to 0 or something like that. In yp2, I'll be replacing d with 2. Okay. So 8 into 1 by 2 minus 1 whole squared into e power 2x. Okay. So what I'll be having is 8 e power 2x. So finally, yp would be what? 2x squared e power x plus 8 e power 2x. That would be yp. Now, general solution would be what? General solution would be what? Y is equal to yc plus yp. Yc was what? C1 plus C2x e power x plus 2x squared e power x plus 8 e power 2x. This is how I will write the solution completely. Okay. Otherwise, you'll be losing the marks if you don't write it completely like this. In the next video, we'll see how to solve when cos x and sin x are there.